Hello friends, welcome to online lecture series on design of machine elements. In this small video series, we are going to discuss about various topics related to pressure vessels. So, let's begin. So, first of all, we will see the topics that we are going to cover in this lecture series. First, we will be discussing about the introduction to pressure vessels. Then we will see the classification of pressure vessels. After studying the classification, we will be covering the different kinds of stresses which are generated in thin cylindrical shell due to an internal pressure. There are two types of stresses which are generated. The first is circumferential or hoop stress, and second is longitudinal stress. After covering these two stresses, we will move to thin spherical shells which are subjected to internal pressure. Just wait. So, the first one which I told you is thin cylindrical shell, and here it is now thin spherical shell. So there is a difference between cylindrical and spherical shells. So after discussing for the thin shells, we will move to the thick cylindrical shells which are subjected to an internal pressure. For thick cylindrical shells, we will discuss three different kinds of equations: Lam's equation, Bernoulli's equation, and then Clapeyron's equation. Then towards the end of this lecture series, we will be focusing on compound cylindrical shells, and then stresses which are generated in the compound cylindrical shells. So these are the topics that we are going to cover in this small series of design of machine elements. So now let's begin with the introduction. So first of all, why we require pressure vessels? Pressure vessels are used to store fluids under pressure. So based on its name itself, we can see that the name is pressure vessel. So it will contain some pressurized fluid. Now the fluid which is stored inside these vessels may undergo a change of state inside the pressure vessel, as in case of steam boilers. All of you have already studied about steam boilers, in which the water is converted into the steam. So it can go into a phase change, or it may be combined with other reagents, as in the chemical plants. So inside the pressure vessels there are some processes which are also possible. So due to this kind of changes, there will be some form of stresses which will be generated, that we are going to discuss in this series. The pressure vessels are designed with a great care. Why? Because suppose if there is some error while designing these pressure vessels, rupture of pressure vessel can occur. That means it can explode, and if explosion happens, then it may cause a loss of life and property. So this is a very critical component which should be designed with extreme safety standards. The material for making pressure vessels may be brittle such as cast iron, or ductile such as mild steel. So it depends on the application. So it can be brittle as well as it can be ductile material. Now we will move over to classification of pressure vessels. So here first of all we will see this classification based on the dimensions. So the first one is thin shell. as you can see it is written over here, thin shell. So if the wall thickness of the shell T is less than 1/10 of the diameter of the shell, then it is known as thin shell. So here we have two different kinds of the dimensions here. First one is thickness, which is denoted as T, and the second is diameter. So all of you are aware of that shell contains two diameters like this. First is the thickness and second is the diameter. So here, if the wall thickness T is less than 1/10 of the diameter, then it will come into the category of thin shell. Okay. Now next, this kind of thin shells are used in boilers, tanks and pipes. The thick shell here, in which again if we see that the thickness of the shell T, which is greater than 1/10 of the diameter D of the shell. So in case of in a case when we have the thickness greater than D by 10, then this will come in the category of thick shell. Okay. So I hope that this classification is clear to your mind. And thick shells are used in high pressure cylinders, tanks, gun barrels, etc. Now let's see the classification based on the end construction. First is open end. So what does it mean by open end pressure vessel? In this case, the circumferential or hoop stresses are induced by the fluid pressure. That is known as open end. And one example can be a simple cylinder with piston, such as cylinder of pressure. Sorry, there is a correction here. Here it should be press. So this is the example of open end. And in case of closed end, the longitudinal stresses in addition to circumferential stresses are induced. So here if you see, in case of open end, circumferential or hoop stresses are induced, and in case of closed end, longitudinal stresses are induced in addition to the circumferential stresses. So this might be a bit confusing right now to see this classification. However, we are going to discuss these two stresses in detail in the next part. So after studying that, this classification will be clear to you. So the example of closed end is tank. Now let us discuss about the stresses in a thin cylindrical shell due to an internal pressure. So here I hope it is visible to all of you. that there are two kinds of failures that we are going to discuss here. First one is failure of a cylindrical shell along the longitudinal section. As you can see over here, that the failure of cylindrical shell is in the along the longitudinal section, and second kind of failure is the failure of cylindrical shell along the transverse direction, as you can see over here. Now there are few assumptions that we have made while studying this. First is the effect of curvature of the cylinder wall is neglected. So we are not considering this kind of this curvature while discussing the stresses. Second is this assumption is very important here, that tensile stresses are uniformly distributed over the sections of wall. Tensile stresses are here uniformly distributed over the sections of wall. Now this will be a very important assumption over here, because there will be one point of time when we cannot use these assumptions. So that will come in the later stages of this chapter, but you need to keep this in mind, that currently we will consider them uniformly distributed. The next assumption is the effect of restraining actions of the heads at the end of the pressure vessel is neglected. Now you might not be aware here, but at the end of pressure vessels there are heads which are available. There is a separate portion or separate theory of heads of pressure vessels. However, they are not part of this syllabus. So if you want to study, you can read them separately. So this effect of restraining action of heads will be neglected. Now we will be focusing on these two figures. When a thin cylindrical shell is subjected to an internal pressure, it is likely to fail in two ways. First is, it may fail along the longitudinal section, that is circumferentially. As you can see in this, if we focus on the first figure, then what is the circumference? This is called circumference, this entire portion. So it is breaking over through the circumference, and it will split the cylinder into two parts. And the next is, it may fail across transverse section, that is longitudinally, splitting the cylinder into two cylindrical shells, as you can see over here. So first we will be discussing about the circumferential or hoop stress. Here this figure is important. This is the detailed figure of this portion. Now we are focusing on this part right now. Okay, so here this is the view of the shell, and this will be the cross section of the shell, in which this P is internal pressure, T is the thickness of the shell, and D is the diameter of the shell. So consider a thin cylindrical shell which is subjected to an internal pressure. So here a tensile stress is acting in the tangential to the circumference, is called as circumferential or hoop stress. A tensile stress acting in the direction tangential to the circumference is known as Tangential is known as circumferential or a hoop stress. Now P is the intensity of internal pressure, D is the internal diameter of cylindrical shell, length L, T is the thickness, and sigma T1 is the circumferential or hoop stress for the material of the cylindrical shell. So now let's prove this equation. So for that we need to copy this into our whiteboard. So let's begin here the derivation for this. So let's begin. First of all, we will write down the total force. Total force acting on longitudinal section. Of shell. So total force is calculated using a simple formula, that is pressure into projected area. So this is equal to pressure into, if we see the projected area in this case, so this is the length L and the diameter D. So as it is happening, this force is, this pressure is on the circumferential direction, so here it will be D into L. So this is the total force. Now there will be some stress which will be generated resisting this force, so that will be resisting force on cylindrical wall. So this will be equal to sigma T1 into, now here there is one interesting part. As you can see, in this case it is breaking in this way. So we need to calculate this region. So as you can see that it is the length is L and this thickness is T. However, it is breaking from the two sides, so we need to count it twice. So it should be 2 T L, because there are two sections. So this will be our equation 1 and this will be our equation 2. So now we can equate these two. So comparing them, we will have P D L is equal to sigma T1 to T L. So L will get cancelled. Then we can obtain sigma T1 is equal to PD upon 2T. Or if we need to calculate the thickness, then we can write down or T is equal to PD upon 2 sigma T. That's it. So here now let's copy this portion in our presentation. So we have derived it. So as you can see, this is the final equation of circumferential or hoop stress and a thickness based on it, PD upon 2T and PD upon 2 sigma T. Now let's discuss about the longitudinal stress. So in this case, this is the way it will break through the length. So consider a closed thin cylindrical shell subjected to an internal pressure as shown in the figure. A tensile stress acting in the direction of axis is known as longitudinal stress. In other words, it is a tensile stress acting on the transverse or circumferential section YY. Let sigma 2T is sigma T2 as longitudinal stress. Now we will derive it. So for that, again we will copy this in our whiteboard. Over here. Now let's begin. Total force acting on transverse direction so in this case it will be again pressure into area. So it should be P into pi by 4 d square. As you can see, it is quite evident from the figure that the area will be pi by 4 d square through which this pressure is acting. Now again there will be the resisting force that will come into picture. Which is equal to sigma T2 into pi dt. If you carefully see this portion over here, let me show it. This area is if you calculate, it will be pi d into t. Now again we will be comparing these two equations, equation 1 and equation 2. So when we equate them, implies that here P into pi by 4 d square is equal to sigma T2 into pi dt. So 1 d will get cancelled out, pi will go. So we can say that sigma T2 is equal to P into d divided by 4t. And if we need to get the thickness value, then T is equal to Pd divided by 4 sigma T2. So that's it. So now let me copy this portion over here. So now in this case, if you compare this equation in which the hoop stress or circumferential stress is Pd upon 2t, while in case of this stress, longitudinal stress, here it is Pd upon 4t. So we can write down over here, maybe as a part of conclusion for this lecture, that sigma T2 is equal to sigma T1 divided by 2. You can check it by yourself that we can write down this equation also. So here we have discussed this portion. Now the next topic is thin spherical shells which are subjected to an internal pressure. However, we will continue this portion or this topic in our next lecture. So let us quickly revise what we have done in today's lecture. That we started with this topic, pressure vessels, which is part of design of machine elements, and the topics which are covered are introduction, classification of pressure vessels, and stresses which are generated in thin cylindrical shell, that is we have discussed today circumferential and longitudinal stress. The remaining topic will be discussed later on. So we went through the introduction, we classified according to dimensions and end construction, then we discussed about the stresses with assumptions, and then we discussed circumferential or hoop stress, and then we derived the equation, and the second stress is longitudinal stress, and we also derived the equation for the same. In next lecture we will start our thin spherical shells which are also subjected to internal pressure. So that is the end of our first lecture on pressure vessels. Thank you for watching this video.